Hello everyone, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. Now, as you know, I've been making quite a bit of progress with the milling machine over the last few days, and it's going really well. And there is still quite a long way to go with it. There's quite a lot to do in the gearbox and still some painting to do and other bits and pieces. But I'm starting to see the light at the end of the tunnel with it now. And I'm starting to tentatively think about what I'm going to do next as a project. Well, I say tentatively, I have made some fairly big steps in the direction of what the next project will be. Now, you remember a few months ago, or perhaps last year even now it is, I was going down a little side project route of a gas turbine. Well, I've gone one stage better than that, and I have actually bought a gas turbine engine. Now, I bought it sight unseen, and what could possibly go wrong when you buy things sight unseen? But anyway, what it is, it's a Rover 10201 Airborne Auxiliary Power Unit. I bought it from a company that deals in old gas turbine engines and spares, and they claimed it was removed from a Hawker Siddeley 748 aircraft, which I don't think is true, because they were actually fitted to the Armstrong Whitworth Argosy, which was a turboprop transport aircraft, and we'll talk a little bit more about that in a minute. But what I want to do today is go through a little bit of history of the Rover gas turbines, what they were used for and how they came about, and then I want to show you some literature and a really special book that I've managed to get hold of, which will really help us in the restoration and rebuild of this gas turbine. So why have I bought a gas turbine? Good question. Well, I've been trying to think hard about the direction I want the workshop and the channel to go in, and I've taken inspiration from my brother at Retro Mechanica, who does restoration work on BSA motorcycles. I've taken inspiration from Mr. Hughes, Joe Hughes, who on his channel does a lot of British military vehicle restoration. And for some time now, I've been wanting to get into this sphere of aircraft restoration because, as you know, that's my background. I was an aircraft engineer in the Royal Air Force. Now, there's an aircraft museum about 7 miles away from me here, Moravia, which Harry and I go to on a regular basis, and we've even made a film there, which is worth a watch if you'd like to see what the place is like. Now, there's no way I can get an aircraft into my workshop here, not even a very small cardboard cutout of one, as you'll all know if you've watched me for any length of time. But what I can do is I can look at aircraft components and aircraft parts, and the best thing I can do, I think, is to get a small gas turbine like an APU or Airborne Auxiliary Power Unit and try to refurbish it and get it running. And that's what I want to do with the engine that I've bought. I want to try to get it restored and up and running so that we can build it into some kind of a frame on wheels, and we can have a tank, a fuel tank and an oil tank and all the rest of it, and we can actually run this thing up and you know, make it do what it's supposed to do, so we can demonstrate how it worked to a crowd of people. And the museum, Moravia, I'm sort of working in conjunction with them on this as well, because they've very kindly allowed me to have the engine delivered to their museum, because I can't really store it here. I don't have anywhere to store it until I can get to work on it. So it's being delivered to Moravia. They're going to look after it for me until I can get onto it and do anything meaningful with it, because I've still got a lot to do on the milling machine, as you're aware. Now, when it does arrive at Moravia, which will be within a week or so, when I get back from work, we'll go down there, we'll have a look at it, we'll try to make an assessment of what it's like, what condition it's in, because the first thing we need to know is, are we going to be able to get this thing running, or is it going to be a waste of time? It's a really good engine. It's a Rover Airborne Auxiliary Power Unit, and we'll talk a bit more about that in a minute. It's got a hydraulic pump on it to provide hydraulic power. It's got a DC electric generator to provide electrical power, which is also the starter motor for it as well. So it's a really interesting thing, and we can have hydraulic power coming from it. We can have the electrics working. You know, we can really build it into something that's going to show how this thing operated when it was fitted into an aircraft. and we'll talk about what aircraft it was fitted into in a minute as well. But before we go any further, I just want to have a quick bit of history on Rover gas turbines. So that's what we'll look at now. Right, so let's have a quick chat about Rover gas turbines. Now, the Rover company is a British firm, and they were probably, well, they were best known for their cars, really. They were a car manufacturer, but from the start of World War II, they'd begun having an interest in gas turbines, and especially they were looking into small gas turbines that could be used for automotive applications and just for kind of general portable power. Now, I'm looking at my notes here because I want to get all this right. So the start into the gas turbine world for Rover really was the 1S60 engine, which was used for things like fire pumps and small portable power units and that type of thing. They were also built into stands and used for university demonstration models of this new technology of the gas turbine, and some of them had dynos fitted to them and things like this, so that engineering students could actually learn how a gas turbine works. Now, I'll put a picture of one of those up as well when I finish this little talk. They then moved into the early 50s. In 1950, they built their first gas turbine powered car, which was called the Jet 1, and I'll put a picture of that up as well. It was quite successful. That led to, by 1961, they brought in the T4, which was a turbine powered saloon car based on the Rover P6. And that had an engine in it that had been developed from this point. The 1S60 was one shaft, 60 horsepower, hence 1S60. By this point, they had the 2S140, so it was twin shaft, two shafts, so it had a free power turbine to drive the gearbox and drive the wheels, and it was 140 horsepower. So it was a 2S140 engine that drove the T4 turbine saloon car. They then moved into the area of racing. So with British Racing Motors, BRM, they built a Le Mans car in 1965. That did really well in the Le Mans 24-hour race. And that had a 2S140 in it as well, I believe, which was kind of upgraded to 150 horsepower, something like that. So it did pretty well in the Le Mans. Now, they then started to build, or in tandem with that, they were building auxiliary power unit gas turbines for aircraft as well, and a lot of British aircraft had Rover APUs in them. So, for example, they built, they're numbered 10201, 10301, like that. So there was 5 gas turbines that were built as APUs. There was the 10201, the 301, 401, and 501. And they were all basically the same, built around the same core, but they all did slightly different jobs. So, for example, the 10201 was used in the Armstrong Whitworth Argosy transport aircraft, which was a four propeller turboprop transport aircraft with 4 Rolls-Royce Dart engines, and it had a Rover APU in it, or it was actually called an AAPU, Airborne Auxiliary Power Unit, because it drove a hydraulic pump and it drove a DC generator to give power to operate hydraulic functions like the doors, cargo doors, and things like that on the ground without having the engines running. So you could operate from rough strips and that type of thing. Then the 10301 was quite similar. That was used in the Avro Vulcan bomber, big nuclear bomber, big delta wing nuclear bomber, and that engine drove a an AC generator to give 200 volts at 400 hertz, because on the Vulcan the flying controls were hydraulic, but each one had its own little electric motor powered pump, and it also gave some bleed air from the compressor for air conditioning and that type of thing on the ground. The 10401 was basically the 2S140 that was in the turbine saloon car, very similar to that. That was used in the Hawker Siddeley 748 civil aircraft, which was like a twin turboprop feeder airliner from the 60s and 70s, and was used into the 80s, early 80s, I think. And the 10501, which was in the aircraft that's close to my heart, the Nimrod, the Hawker Siddeley Nimrod, which was built as it was originally came from the Comet airliner, and it was actually an anti-submarine warfare aircraft. and that had the that version of the APU that was in it just drove a compressor which was used to provide starting air for the engines. Now, as I said, they're all basically the same engine, just with variations on a theme. The one I have bought is a 10201, which was used in the Armstrong Whitworth Argosy aircraft, Armstrong Whitworth of British Standard Whitworth thread fame. And that was the last aircraft they ever designed and built themselves. And it went out of service with the Royal Air Force in 1978, so it was actually in service for quite a long time. And it was known as the whistling wheelbarrow because it had like a twin fuselage at the back that looked like the handles of a wheelbarrow and the nose wheel at the front, so it looked like a wheelbarrow. That was what it was called. So as I said to you before, this 10201 engine, it had a hydraulic pump for driving auxiliaries and it had a DC generator. So to actually get that engine, if we can get it running, it will be really interesting to see it because we can have the hydraulic pressure building up, we can have the DC generator providing power, and it's got a gearbox on it to drive those auxiliaries. To my mind, it's the most interesting out of those 4 engines that were built for aircraft use. It's the most interesting one, and it'll be the nicest one to work on and actually have running. So I'm going to show you something really special now as well. So it's a book. So we'll get over to the other bench and we'll have a look at this special book. So before I show you this special book, as I'm referring to it, I want to show you something else first. And this is some literature that I have in my collection. This is the 10501 Rover APU that was used in the Nimrod aircraft that I worked on for many years. So here's a cutaway diagram of it. You can see here the starter motor, oil filter, here's the compressor, here's the turbine, combustion chambers, and this is the big centrifugal compressor that it drove that was then used to provide air to start the main engines, which were Spey 250s in the Nimrod. Here's another view of the back of the engine, showing the various auxiliaries, the starter motor, fuel pump, and HP fuel solenoid and the filter. And here's a side view of it here where you can see all the bits that I've just referred to. This is where the combustion chamber is in here and the turbine. And if I turn the page over, you can see, if I can manage to do it. So we'll just move the camera a little bit and tilt it up so you can see this. So that's an image there of how it was installed in the aircraft. Try and zoom in on that for you. That's better, isn't it? So you can see there, it was installed in the rear fuselage, and you can see here, look how they had the oil tank external to it, and it was installed in like a fireproof box with just the rear end of it protruding, and there's the exhaust here, and then the air going off to start the engines from the compressor. And at the bottom of the page, which I'll now show you, I'll just move down, is a little diagram which is of great interest because it shows you the fuel system and how it has in the in this engine system, it has this air pump. And the way these engines worked was they used to have a fuel injector which was air assisted to better atomize the fuel, and it basically took a tapping from the P2 pressure from the compressor outlet and used that to assist the atomization of the fuel. And when the engine was started, before it had run up to full speed, it had this electrically driven air pump which used to blast air through the fuel injector in order to help to atomize it before the engine had got up to full speed. So that's a really clever little innovation, I've always thought. But anyway, having looked at that installation of the 10501 in the Nimrod, I'll now show you the special book. So here is the special book. What we have here is a Royal Air Force aircraft publication, an aircraft technical manual, in other words, and this is Air Publication 102F0203-16A, to those of you in the know. And you can see here it is Rover Airborne Auxiliary Power Plant Mark 10201. So when I saw the 10201 gas turbine engine for sale, I thought, oh, that looks really interesting. I think I could do something with that if I can get my hands on it. And then a couple of days after I'd looked at that, I saw this manual on the same auction site, and I thought to myself, that is a sign. I have been given a sign. I have to buy this manual and I have to buy the engine, because this book contains all the information that is required to service, repair and refurbish one of these engines. And what I'd like to do now is I'll open the book up and I'll start showing you some of the pages, because this thing is absolute gold dust. So as soon as we open this book, we're into gem territory straight away. Here is the Rover Mark 10201 AAPU, and that's a cutaway of the nacelle, so you can see the internal bits and pieces. And these nacelles, they actually come off, and I'll show you that in a second in another illustration. But here we can see, I'll get up something to point with. I'm holding the camera by hand, so apologies. Here's the air assistance pump that I spoke about on the 10501 in the Nimrod. Here's the DC generator here, look. This is a blower that's driven from the gearbox as well. There's a oil cooler here. Can't get my words out. An oil cooler, and the blower also supplies cooling air for the generator. And we've got various electrical connections here for the bits and pieces. We've got an oil tank here, and there's also another oil tank here. And then if we look at, that was the starboard side. If we look at the port side, we can see here's our hydraulic pump driven from the same gearbox. We've got hoses running up to connections on the top of the nacelle. And we can also see the other side view of the oil cooler here. And we've got low pressure fuel filter. There's various other bits and pieces that we can look at. And I'll show you a photograph now, or a picture, one of these half-tone illustrations of the engine with the nacelles removed. Before we do that, here's a front and rear view. So here you can see, here's the back end of the electric air pump, the air assistance pump. Here's the oil cooler, and the blower is here. Here's the 24 volt DC generator. Here is the hydraulic pump, and on top there's the couplings. So these hoses run into there, so you can couple up your hydraulic pump to the system, hydraulic system. And you can see here there's an oil filter. You've got the oil catch tank at the bottom here, low pressure fuel filter, and all the other bits and pieces that are required to make the engine run. So this is another illustration of the engine which is unencumbered by the nacelles. So they've given us the outline of the hydraulic pump here, and that's so we can see the fuel pump, which is down there, and the fuel pump has a temperature control unit on it, which is controlled by a mercury capillary line. We've got here the oil cooler, the 24 volt DC generator. We've got the combustion chamber here, which has the burner or the fuel injector. And we've got this line here coming up from the air pump, which goes into the burner to give some air assistance for the atomization. We have the burner actuator here, which is a Rotax actuator. That's basically operating a valve inside there to open and close the fuel into the burner. And then the compressor housing is here, and the gearbox is all attached onto the back of here. Here's another photograph, look, well, a picture rather. We can see the air pump, the oil catch tank, what they call a re-oil valve tray, and the exhaust cone assembly here. And then if I pull this leaf out here, look, you can see a cutaway of the inside of the engine. If I can get this, I'm going to be really careful with this because I don't want to damage it at all in any way, shape or form. So there is the combustion chamber, there's the burner, there's the actuator, there's the plenum for the hot gases. Here we have the turbine. Here is the compressor. Here is the compressor. And then we've got the what they call the high-speed pinion, which then goes onto the gearbox. Here's the gearbox. Here's the fuel pump and its temperature control unit. Fuel pump quill drive shaft. There's the oil pump for lubrication. The suction strainer for the oil pump. The generator. So we can see that's a really good diagram of the engine. And as we move through, these books are absolutely superb. Everything they're in them is explained, and they are a masterpiece of technical literature. They go about it by explaining how each and every single component in the system, from the smallest check valve to the most complex fuel pump or hydraulic pump, exactly how it works, and then the role it plays in the system. So here we've got the compressor and turbine on their shafts with a labyrinth seal, a roller bearing at one side for the turbine, and another bearing for the compressor. We've got the high-speed pinion that I spoke about before. I'll carry on just flipping pages. Here we've got the compressor housing, which also incorporates the gearbox mounting face. We've got the rear bearing for the and the diffuser vanes for the compressor. The compressor shaft rear oil seal. This is the bearing seal system for the compressor and lubrication system, and how basically they're using air here to seal it. That's the turbine nozzle and shroud ring. Here's the combustion chamber, so that's a really good view of the combustion chamber with the burner. The fuel feed pipe here, fuel drain, because this uses a type of atomizer, swirl atomizer, where they basically pump fuel in at a certain pressure, and they bleed some off, and that maintains the fuel pressure in there to give good atomization all the time. Here's the air assistance pipe, which comes from the air pump that we saw. Here's the igniter plug. There's the burner actuator. This combustion chamber is a really interesting design. It's almost built like a rocket thrust chamber, where you've got a nozzle here past the primary section. Where it goes into the dilution section, you've got this nozzle like a throat. You've also got vortex jets here as well to make sure that the secondary air gets well mixed in with the primary air. That's the volute casing, where the air from the compressor runs into the combustion chamber. So this bit here is here on the combustion chamber. More views of the bellows, exhaust cone, and the duct assembly. Here is the gearbox, so the auxiliary gearbox with the oil filter mounted on the back of it, full flow oil filter. Here are the gear trains for driving various different bits and pieces. So we've got idler gears in here, we've got the generator drive gear, we've got the hydraulic pump drive here, which is like a quill drive, and the fuel pump drive comes off there. I'll just keep randomly turning the pages. There's the generator drive assembly, there's the gearbox gear train. That's the generator drive, as I said. Here is the gearbox cover, the blower unit drive. I mean, this is just it's just a trove of information. It's the sort of thing I love just to pore over, but I've got a reason to do it now, because I've actually got the real thing to play with. So there's the air and gas flow diagram, and then now we're moving into the oil system, the lubrication system. So this gives us here. Sorry about the camera view there. There's a diagram of the lubrication system through the cooler, and from the sump, basically where the oil gets pumped, to the bearings of the engine and the gearbox and the oil cooler. Here's the oil pump assembly and where it fits into the sump. So basically what this is doing is it's showing us exactly how everything works, and then it goes on to show us how we service it and maintain it. That's the oil catch tank. There's the filter. This is the blower unit that blows air through the generator, and also the heat exchanger for the oil cooler. There's the oil cooler with its differential pressure switch. Moving on to the fuel system. So there we go, look, there's the fuel system. Let's just pull this leaf out for you so you can see it. There's the air assistance pump, fuel pump. There's the burner with its actuator, and it's just a valve in there. The atomizer assembly. The blue is where the air comes, look, from the... so basically it gets sucked in through the filter, pumped by the air pump, goes through this check valve, into the annulus of the burner, and then as this atomized fuel comes out from the swirl plug, it then hits the air hits it and blasts it into even smaller droplets. And this here where it says P2 probe, this is coming from the compressor outlet, so it can either feed from the compressor outlet into the injector, or it can feed from the air pump, and this check valve here stops it from back feeding. If it's coming from the P2, it doesn't go into the air pump and vice versa. There's another view of the air pump. There's the fuel pump and its attendant temperature control system, which is controlled by what they call a mercury boiler, which is just a mercury capillary tube. When it gets too hot, it feeds into here and it acts on the governor to back off the fuel slightly. And you can see it there, look. It's like a Borden tube basically with mercury inside it. There's the actuator for the burner, or the fuel injector as it should more appropriately be called, and you can see the swirl plug there and the annulus where the assisting air comes through. There's the motorized air pump, as they call it, the air assistance pump. We've got ignition and electrics now. So functions of all the plugs. There's the igniter plug. Here's the layout of the wiring and the pin out of everything. So it's pretty simple electrically. High energy ignition unit should be in there somewhere for driving the igniter plug, which is here. Those are the thermocouples. I thought that was the igniter plug, but it's the exhaust thermocouples. There's the igniter plug, so HEIU must be somewhere, but it's not shown on this picture. We might have to try and get hold of one of those from somewhere. So I'll carry on. I'll show you some of the other pages. There's the hydraulic pump, the hydraulic installation. I just love this. It's a feast for my eyes, this thing. There's the hydraulic pump, which is a Mark 68, I think. It's built-in unloading valve, essentially. Some aircraft, the Nimrod had this part of the pump on the engine, and then this part here, it was a separate valve called an ACOV, automatic changeover valve, and this type of pump is built in. So essentially this type of system has to have an accumulator to give a time constant, so it builds up pressure against the accumulator. That then opens a valve in this unloader and it goes offload rather, and then as soon as pressure in the system is demanded, the accumulator pressure drops ever so slightly, and then this will kick back in to pump that back up. That's how it works. There's how it's fitted. But it goes on to give lots of other information, servicing information, you know, it's all in here, even what tools you need, minor repairs. But there's a really, really important section that I'm going to show you now that will be really helpful to us for rebuilding and refurbishing. So what we're looking at now is section 6 of the AP, which is the fits, limits and tolerances section. So what this gives us, it doesn't look very interesting, but what it gives us is all the components, all the mechanical components of the engine, and it gives us all the fits, limits and clearances that are permissible, what they are from new and what they are permissible as worn. So that allows us to make decisions on all the components in the engine and how, if they need to be repaired, and if we need to make sleeves, or if we need to do anything with them, build anything up, or if anything needs to be replaced. So this will really help us when we come to refurbishing the engine, to examine all the components, see if they're within tolerance. What's that? That's the intermediate drive gear, look, and it shows you all the fits, clearances and tolerances for everything here. So that will help us when we come to refurbish the engine to get it into a running condition, if that is at all possible, by giving us all the fits, clearances and tolerances that we need to make decisions on the serviceability of all of the components. As you can tell, I am like a child with a new toy with this. So I'm going to close out the video there. I hope I haven't bored you to death looking at all these books and talking about one of my favorite subjects. I'm going back to work later today. I just wanted to get this video out just to give you some idea of what is going to be happening in the future. And I'm really looking forward to the engine turning up and to being able to have a look at it when I get back from work. You can bet your life that one of the first things I'll be doing is going down to Moravia and having a look at the engine, and I'll take the camera with me, and you'll be the first. Well, actually, no, that's not strictly true, is it? You'll be the second ones to get to know about it. So yeah, I'll have a look at it then. So until that time, all that remains for me to say is thank you very much for watching my videos. Thank you very much for subscribing. If you're not subscribed, please do so. As you can see, I've got some interesting things coming up once we've got the milling machine out of the way. But we will be paying visits to Moravia, where the engine's going to be stored. We'll maybe be taking bits off it. We'll be having a look at it, trying to assess the serviceability or otherwise of it. After all, I may have just wasted a lot of money, but we'll find out. But if you're not subscribed, as I said, please consider doing so. It could just well be worth it. Anyway, see you all again next time, and take care of yourselves.